everyone, and welcome back to our channel. And today we are going to look at the chapter on playing with numbers. So, in today's lecture, we are going to look at the following contents. First, we will look at how the number looks in a general form. Then, we will look at what happens when we reverse a 2 or a 3-digit number and what are the interesting properties that come out of it. Then we will look at some interesting number puzzles, which can be in diagrammatical form or in expression form. And finally, we will look at divisibility tests for different kinds of numbers. And they include 10, 5, 2, 3, 9, 4, 8, 6, 11, and 7. So let's get started. So number in a general form can be written in the following way. So let's take an example of number 35. This can be written in the general form as 30 plus 5, or which can be further simplified is 10 into 3 plus 5. Similarly, we can also write something like 49, and this could be written as 40 plus 9, or 10 into 4 plus 9. So how do we write this in a general form? For a two-digit number, we have, say, AB, where AB is not equal to A into B, and it can be written in the form of 10 into A plus B, or 10A plus B. And if we reverse this, we will have BA, which can be written as 10B plus A. Similarly, let's try a three-digit number. So let's take an example of 945. So this can be written as 900 plus 40 plus 5, and this can be further written as 100 into 9 plus 10 into 10 into 4 plus 5. And let's write this in a general form again. And this can be written as ABC. So we will have 100A plus 10B plus C. Let's reverse this and have CBA, and this can be written as 100C plus 10B plus A. And we can reverse or circulate it in any way we like. So we have a question where we have a two-digit number where the tenth digit is twice that of the unit digit. And if the sum of the digit is 9, let's find that number. So if it is a two-digit number, then it would be AB, or it can be written as 10A plus B. So here we have the unit digit, which is B, and the tenth digit, that is A. And through the condition in the problem, we have the tenth digit, that is A, is twice the unit digit, that is B. So A is equal to 2B. And the other thing is the sum of digits is 9. So A plus B is equal to 9. So let's substitute the value of A in the second equation. So 2B plus B is equal to 9. 3B is equal to 9. So B is equal to 3. And A is equal to 2 into 3, which is equal to 6. So A is equal to 6 and B is equal to 3. And our number AB, that is 10A plus B, is equal to 10 into 6 plus 3, which is equal to 63. So now let's look at some interesting properties when we reverse a two-digit number. Let's take a two-digit number 86. The reverse of it is 68. And let's add these two numbers. So 86 plus 68 is 154. Now the sum 154 can be written as 11 into 14. Let's observe this very closely. So we have two numbers with which 154 is divisible, and that is 11 and 14. 11 is on its own, but 14 is special because it is the sum of 6 and 8 of the two digits. So this brings us to a very useful property, a very interesting property. So for any two-digit number AB, which is 10A plus B, with the reverse BA, that is 10B plus A, and on adding these two numbers, we will get 10a plus b plus 10b plus a, which gives us 11a plus 11b, or 11, we can take that out as the common factor, a plus b. So any two-digit number would be divisible to 11 and the sum of its digits a and b. And that's what we showed in the example above of 86 and 68. Let's again consider another two-digit number, 83. The reverse of this is 38. And now let's take the difference of these two numbers. So 83 minus 38 is equal to 45. And when we try and find the numbers that 45 is divisible with, we find it is 9 and 5. So in these two numbers, 5 is the special one, as it is the difference of these two digits, 8 and 3. So this is an interesting property again of reversing any two-digit number. And let us write it in a general form. So let's consider the two-digit number AB, where A is less than B, and the reverse is BA. So the two numbers are 10A plus B and 10B plus A. So on subtracting the smaller number from the larger number, we get 10A plus B minus 10B plus A, which gives us 9A minus 9B. And we can take 9 as common, and then we get A minus B. So this is again the same as above, where we have the difference that is divisible with 9 and the difference of the two digits of the two-digit number. Let's similarly look at what happens when this is a three-digit number. Let's consider a number 975, and the reverse of this digit is 579. Let's take the difference of these two numbers. So 975 minus 579 is equal to 396. Let's see what 396 is divisible with. So we find that it is divisible with 99 into 4. So in this, 4 is the special number because this comes out as the difference of the digits in the hundreds and the unit digit place. And that is 9 and 5. So whatever you have in the hundreds digit and what you have in the units in it digit, the difference between these two digits would be divisible by the difference of the two numbers. So let's write this in a general form. So let's consider a number ABC, and that can be written as 100A plus 10B plus C, and A is greater than C. So the difference, if A is greater than C, comes out to be 19, comes out to be divisible with 99 and the difference of A and C. Similarly, if A is less than C, the difference would be reverse. I would not show the whole process. The difference would be divisible with 99 C minus A. And in the third part where A is equal to C, then the difference would be 0. Next, we have another interesting property about a three-digit number when we look at it in a cyclical manner. So let's take a three-digit number, that is 752. So when we cyclically change this, let me create a diagram, 7, 5 and 2. So it should be like in a cyclical manner. So these numbers could be 527 and 275. If we take the sum of these numbers, so let's take 752 plus 527 plus 275, we get 1554. Let's try to find what is divisible with this number. So we get 111 into 14, or 37 into 3 into 14. So the sum of all these numbers is divisible by 111, 14, 3 and 37. So out of all these numbers, the special one is 14, which is special because it is sum of the digits 7, 5 and 2. So let's try to write this in a general form. So let's take a 3-digit number ABC, which is 100A plus 10B plus C. In cyclical manner, we can also write BCA, which is 100B plus 10C plus A, and CAB, which is 100C plus 10A plus B. When we add these numbers, ABC plus BCA plus CAB, we get 111A plus 111B plus 111C. We can simplify this by taking out 111. A plus B plus C would be left out. And then we can then also write it as 3 into 37, as we wrote it before, into A plus B plus C. And that's how this cyclical movement pattern of a 3-digit number works. And it will be divisible by the sum of digits A, B, C, 111, 3 and 37. So let's look at this question. So we need to write the quotient when the quotient of a sum of 3-digit number 571 and the number obtained by reversing the digit is divided by these four numbers, which are 99, 4, 3 and 33. Try this question. So our given number is 571 and the reverse is 175. So the difference of these two numbers is 396. And let's try to find the numbers which are divisible by it. So we get 99 and 4. And when the difference is divided by 99, the quotient will be 4. When this is divided by 4, the quotient will be 99. When this is divided by 3, the quotient will be 33 into 4. And when it is divided by 33, the quotient will be 3 into 4. So that's how we get that. Now it's time for some puzzles. So the puzzles have two rules. First of all, the first rule is each letter will only have one digit only. And the next one is the first digit cannot be 0, i.e. something like 0065 or 065. No, the number should be 65. So let's look at a couple of examples, A and B, in the following setting. So in this, we need to find the values of A and B. So let's see what happens. So let's first look at the units column, which is A and B. When we add that, we should get 9. So A and B, the maximum value of each can be 9 and 9. So the sum of A plus B cannot exceed 18. So let's make that note. A plus B cannot exceed. I hope you are understanding this. It can't exceed 18 because both the numbers can't exceed 9 on itself. So how do we get 9 by adding the 2? So we need to find something. So this number A plus B cannot be 19. So it will be A plus B would be 9 on its own. And the possibilities would be A can be 1, then B would be 8, A can be 2, then B would be 7, and so on. We'll observe the other columns before making a decision what happens in this column. So now let's look at the tens column. So we have 2 plus A, which should come out to be something with a units digit of 0. So the 2 plus A cannot exceed, what value can't it exceed? So we already know 2 and we know the max value of A can be 9. So 2 plus A cannot exceed 11. I hope this is very clear because the max value of 2 is going to be 2 and the max value of A is going to be 9. So how do we know what value would be 2 and A? So 2 plus A can only be 10 at the moment. So now that we know 2 plus A is equal to 10 and we are very sure of it and we only need to find one value. So A would be done by solving this. So 10 minus 2 is 8. So A becomes 8. And then we can also find b, because we now know the value of a. So a plus b is equal to 9. So we know 8 plus b is equal to 9. So b becomes 1. We can also check whether our answer is correct or not by putting these values. So let's put a here, 8 here, 1 here, and the sum of those two would become 9. And then we have a here. So 2 and 8 would become 10. And then we go to the hundreds place. So 1 plus 1 plus 6 would become 8 again. So that's correct. Now let's look at a multiplication problem. So we'll find when AB into 3 is equal to CAB. So let's observe the units column. So we see that the units digit is B. Even when multiplying it with any number, say 3. So B into 3 would again give some number with unit digit B. This can only happen if B is equal to 5 or B is equal to 0. I hope you understand this. So say we have 5 into 3 is 15, 5 into 5 is 25. And even if we put 0 or say 10, so 10 into 3 is 30, then we have 0 again. 10 into 2 is 20, then we have 0 again. So that's how it goes. So if we multiply b with 3, the unit digit is only going to be the same digit b. So this can only be 5 or 0. So now we know the value of b. So we'll just put that here. So 3 into 5 we know is 15. So 1 goes here. We can write another equation which satisfies this whole thing. So we have 3 into a plus b is equal to, 3 into a plus 1 is equal to ca. So we'll have another equation from this, which will be 3 into a plus 1 is equal to ca, right? So now we need to find a multiplication of 3 by a and then add one number to it whose unit digit again becomes a. So now if a has value of anything between 1 to 9, then on checking them, we find that no value satisfies this equation. So the only way this might happen is when b is equal to 0. So because this equation is not satisfied by any number, from 1 to 9, then b is not equal to 5 and it is therefore equal to 0. So let's try and observe how should we proceed if b is equal to 5. So a0 into 3, ca0. So let's write the new equation where we have 3a is equal to ca. So here a cancels out and c is equal to 3. So this value is only possible when a is equal to when a is equal to 5. Let me show that to you. 3 into 5 becomes 15. So from this equation we can find c and a values. So c is equal to 1, a is equal to 5, and we have already seen b is equal to 0. And that's how we find that out. So let's do this diagrammatic question. So what we need to do in this question is that we need to complete the square using digits from 1 to 9 by using them once only. So the sum of each row, each column, let me show what a row and a column is. So this is a row, this is a column, and this is a diagonal. So the sum along all these lines should be 15. So let's try and find out using a rough hand what happens in each of these. So let's try to find values where everything is present. Let's take the values x here and y here and z here. So we know that 8 plus 3 plus x should come out to be 15. So x would come out to be 4. So we'll write 4 over here. Next, we have another called the diagonal. 8 plus 5 plus y would again give us 15. So y is 2. Now we have so many upcoming. So now we can put up as z. So in this diagonal, 5 plus 4 plus z is equal to 15 again. So our z value becomes 6. And now we can complete the rows as, so we have 6 plus 8 plus this number should be 15. 6 plus 8 is 14. So we get 15 minus 14 as 1 over here. Again, we have 2 and 4. The sum of these is 6. So 15 minus 6 would be 9. So the 9 comes over here. And then again, we have 6 plus 2 is 8. 15 minus 8 is 7. And that's how we complete this magical square. I hope you like this.